Hello guys, in today's video we are solving trigonometry which was written in November 2021. So without wasting any more time, let's go straight to the questions. Without using a calculator, simplify the following expression to one trigonometric ratio. Sine 140 degrees multiplied by sine 360 minus x all over cos 50 times tan minus x. So to solve this expression, we have to expand, we have to reduce, somewhere we have to equalize with identities. Yeah, so like sine 140 degrees, we can refer it from a horizontal line or vertical line. Like you can say sine 180 degrees minus 40. 180 degrees minus 40 is the same as 140. So here can say, can just write it the way it is, and then over cos 50, because already I've got 40 here. In cos 50 I can write cos vertical line 90 minus 40 is the same as 50 multiplied by tan minus x. So here I expanded my angles, then now I have to reduce them. And to reduce them, we need cast sketch. Like cast sketch helps us to identify a sign that is in a particular quadrant. Like here it's 0, 90 degrees, 180 degrees, 270 degrees. From 0 to 90 degrees, all ratios are positive. All everything is positive. 90 degrees to 180 degrees, which is second quadrant, only sine is positive. And then from 180 to 270, only tan is positive. And then from 270 to 360 or 0 degrees, then only cos is positive. So here we've got sine 180 minus is the second quadrant. In second quadrant, only sine is positive. So this means we are going to have positive sine 40 multiplied by sine 360 minus x. 360 minus is the fourth quadrant. 360 minus is the fourth quadrant. Only cos is positive. So we are going to have minus sine x over then cos 90 minus 40. So 90 minus on a vertical, if the angle is referred from the vertical line, the ratio will change to its co-function identity. So co-function identity of cos is sine. So and then co-function identity of sine is cos. If it's cos, it changes to sine. If it's sine, it changes to cos. So here we are going to have sine 40. Positive sine 40 because it's 90 minus, and then in this quadrant everything is positive. So here this is positive. Then tan is negative. Tan negative angle is the same as negative tan angle. So here sine 40 will divide sine 40. Then we are left with negative sine x over, and then 10, you can write 10 as a quotient identity. Quotient identity of 10 is sine x over cos x, and then you can flip and multiply. Minus sine x over 1 multiplied by, then this one will come over and 1 will come down. Here we are going to have cos x over sine x, which is negative. Then the negative will multiply the negative, and then sine x will divide sine x. Then we are left with cos x. This is the answer that is needed. Question number 2. Prove the following identity. Negative 2 sine squared x plus cos x plus 1 over 1 minus cos into 540 minus x equals to 2 cos x minus 1. So when we do proofs in trigonometry, we prove that the complicated side. If you can see this side is complicated, so we have to simplify the complicated side. This one is simplified, so we can't make it complicated. We have to simplify the complicated one. So we are working on this side. If we don't get the answer, if we don't get this answer, then we can work this side. If we get this one, then it's fine. But sometimes when we do proof, we can prove this side and this side also. But let's start with the complicated one. So here you can have negative 2. So another thing, if you can see here, we've got cos, and we've got sine square. We have to change this sine into cos, because here we already have cos and cos. So this sine is going to be difficult to work with it because we've got cos's here. So we have to change this sine squared into cos. You can say 1 minus cos squared x from the square identities. So plus cos x plus 1 over 1. So 540 is like the function already made a full cycle. Now it has returned, it has from 360 still going forward. So you can say 540 minus 360, it's 180. This one is the same as cos 180 minus x. So we know from cast, here is 0, 90, 180, 270, 360, then it's going forward 450, and then 540. This means that our angle is here, it's referred from here. So it's 180 minus, and then here minus is only sign, it's positive. This is cast, cos, all sine, tie. So here only sine is positive. This means cos is negative. So we are going to have the negative, this negative into negative of quadrant, because it's in this quadrant, cos x. And then here we multiply everything by negative 2. Negative 2, we remove the brackets, plus 2 cos squared x plus cos x plus 1 over 1 plus negative times negative is positive cos x. And then here we've got like terms. We've got negative 2, we've got plus 1. So 1 minus 2, it's minus 1. Then we are going to have 2 cos squared x plus cos x minus 1 over 1 plus cos x. Then this is, if you can see this one, it's a quadratic expression, so we have to factorize it, this one. So we have to find factors. So you can say 2 cos squared, no, not cos squared x, 2 cos x, it's not the squared here, and then here you can say cos x, then 1 and 1. Middle term is positive. Then when we multiply this one and this one, we get 2 cos x, and this one, we get only cos x. So this means our positive has to be here, has to be get by bigger number. Then here it's negative over 1 plus cos x, and then 1 plus cos x will divide cos x plus 1. It's the same thing. Then we are left with 2 cos x minus 1. And then it's the same as this one. So this one we have proof. Then left hand side is this equals to the right hand side. Now we are on number 3. Number 3, we are given sine 36 degrees equals to the square root of 1 minus p squared. So the question says, without using a calculator, determine each of the following in terms of p. 3.1 tan 36 degrees. 3.2 cos 108 degrees. So this type of question, you need to draw a sketch before you can solve tan 36, because they say we must not use a calculator. So if they never say that, we will just punch tan 36 degrees, then calculator will do the calculation. So now, because they say without using a calculator, we know that tan 36 degrees equals to y over x. Y over x. So we can substitute y, but we don't have an x. So before we can solve this one, we must find x, y. We must make sure we have x, we have y, we have r. So to find those, we draw a sketch. Let's see, sine 36 in terms of triangle, in terms of the side of a right angle triangle. Sine 36 equals to opposite over hypotenuse. So which is equals to 1 minus p squared over 1. So y is the square root of 1 minus p squared, then r equals to 1. So we can demonstrate it by a sketch, a rough sketch. And then here is 36 degrees, then here is right angle triangle. So sine is opposite, so opposite to this angle is 1 minus p squared, and then opposite over hypotenuse. This is 1. The hypotenuse, the longest side of a right angle triangle, is 1. Then we don't have an x. So for us to be able to solve tan 36 degrees, we must have x. So we have to find x. So because this is a right angle triangle, we can use theorem of Pythagoras to find the value of x. Theorem of Pythagoras is x squared plus y squared equals to r squared. And then x squared equals to r squared minus y squared. So we can substitute 1, our r is 1 squared minus into, then our y is the square root of 1 minus p squared to squared. And then so 1 squared is 1, then minus, then this square root will cancel the square root. So into 1 minus p squared. And then if we multiply everything by -1, this one is going to be -1, this one is going to be positive. So x squared equals to, we are left with p squared, because this one becomes positive if you multiply by -1 here, equals to p squared. And then if we remove it by square root, so x equals to p. It's positive p because it's in the first quadrant. You can't say negative, but negative plus or minus x equals to p. So now we've got the value of x, and then now we can calculate tan 36. Tan 36 degrees equals to y over x. So then y is square root of 1 minus p squared over x is p. And then if it can be simplified, then you simplify, then you find the answer. This one looks like we can go further than here, so you leave it like that. And then here we've got 108, so, and then here we've got 36. We have to relate 108 and 36. If, okay, we can expand this one. You can say cos 180 minus 72. The reason why I choose 72 is because 36 plus 36, it's 72. So it's gonna make us a little bit simpler. And then we know cos in second quadrant in 180 minus, it's negative. So now we've got negative cos 72, which is the same as negative cos 2 times 36 degrees. Yes, and then here the double angle of cos is the same as negative into cos squared 36 degrees minus sine squared 36, not 60, 36 degrees, those brackets, which is the same as sine squared 36 minus cos squared 36. Because when we multiply everything by this negative, this one becomes positive, this one becomes negative. That's why I said sine, I put sine as positive. And then we know that sine is y over r squared. So then cos, it's x over r squared. And our r is 1, so we can just put y only, y squared only. Then y is 1 minus p squared minus, then our x is p squared. Then, so here we are going to have 1, so here is squared here. Yeah, because y is 1 minus p squared. We also have a squared here. So 1 minus p squared minus p squared. And then 1 minus 2p squared. Minus p squared minus p squared is minus 2p squared. And then this is the value of cos 108. And now we are on number 4. Number 4 is given cos alpha minus beta equals to cos alpha times cos beta plus sin alpha times sin beta. Use the identity above to derive a formula of cos alpha plus beta. So with this one, they want us to use the above identity to derive a formula for cos alpha plus beta. So for us to be able to derive this one, we have to write in the form of negative here. We must put negative here so that we can use this identity to derive this one. So we can say the cos alpha minus into minus beta, then it's the same as this one, is the same as alpha plus beta. When we multiply this one, they give us positive. And then at the same time, it's the same as this one because now it's negative. So we can use this identity. So we are going to have cos alpha multiplied by cos into minus beta, because our beta it's negative, and then plus sine alpha multiplied by sine into negative beta. So here we are going to have cos alpha, and then cos negative angle is the same as cos positive angle. It doesn't carry the negative sign, so we write it the way it is, cos beta, then plus sine alpha multiplied by sine negative angle is not behaving like cos negative angle. If it's sine negative angle, then it carries the negative sign, it carries the negative, so we're going to have negative sine beta, and then we can continue. Say cos alpha multiplied by cos beta, then we multiply this negative with this positive, then we will end up having negative sine alpha times sine beta. So the formula for cos alpha plus beta is equal to cos alpha times cos beta minus sine alpha times sine beta. So this is the formula for this one. And then 4.2, simplify. So simplify 2 cos 6x times cos 4x minus cos 10x plus 2 sine squared x. So we can see where is that. We've got 6, we've got 4, and we've got 10. And 6 plus 4 equals to 10. So we have to break this 10. Yeah, so here we can say 2 cos 6x cos 4x minus cos 6x plus 4x plus 2 sine squared x. Then because here we had proved that cos alpha plus beta is the same as this one. So even this one we can write it as like the formula that we had derived. So here we are going to have 2 cos 6x cos 4x minus, then we're gonna write this formula like this formula here, cos 6x multiplied by cos 4x minus sine 6x multiplied by sine 4x plus 2 sine squared x. Then so here we have to remove the brackets. We are going to have 2 cos 6x multiplied by cos 4x minus cos 6x multiplied by cos 4x. This minus and this minus becomes positive. Then sine 6x multiplied by sine 4x plus 2 sine squared x. Then here we've got 2 cos 6x times cos 4x. Here we've got cos 6x times cos 4x. This one and this one are like terms. So we can subtract this one from this one. So here is 1, here is 2. So we left with cos 6x times cos 4x plus sine 6x times sine 4x plus the 2 sine squared x. So if you can see, these two are the compound angle of cos. Yeah. So this one is the same as cos 6x minus 4x. If you can derive 6x minus 4x, we are going to have these two terms, this one and this one. So plus 2 sine squared x. And then this one is the same as cos 2 into x plus 2 sine squared x. And then double angle of cos is the same as 1 minus 2 sine squared x plus, this is the double angle of, this is this, it's the same as cos 2x. This one is the same as cos 2x. So 2 sine squared x is this one. And then minus and positive, this one will subtract this one. So the answer here is 1. And now we are at number 5, which is the last question. Number 5 says determine the general solution of tan x equals to 2 sine 2x, where cos x is less than 0. So cos x is less than 0 at the second quadrant and the third quadrant. So our angles are gonna be there. Before we can start with the angle, we have to simplify this equation. So we have to make it simple so that we can find reference angle. Then we're gonna use reference angle on this quadrant. So tan x is the same as sine x over cos x equals to 2, and then 2 sine x. Let's say sine 2x is the double angle, so it's the same as 2 sine x multiplied by cos x. And then here sine x over cos x can multiply, you're gonna have 4 sine x multiplied by cos x. And then here we make and cross multiples, we're going to have sine x equals to 4 sine x multiplied by cos squared x. Cos multiplied by cos becomes cos x squared x. And then we can move this sine x to the other side. Then this side we left it 0 equals to 4 sine x cos squared x minus sine x. Then so here we can factorize this one by pulling out the common factor. Our common factor is sine x, which is common in both terms. So you can say sine x into, then here we're gonna left with 4 cos squared x. This side we're gonna divide by sine x, we're left with 1. And then because everything here equals to 0, you can say can equalize everything with 0, or 4 cos squared x minus 1 equals to 0. Then we have to find reference angle now. Now we can find the reference angle. So here x equals to arc sine 0, or this side we divide, let's say we move 1 to the other side and divide by 4. So we are going to have cos squared x is equals to 1 over 4. Then if we can put square root here, put square root here. The square root is going to remove the square. And then square root of 4 equals to 2. So we are going to have cos x equals to 1 over 2. And then x equals to arc cos half. So we can press the calculator. Start with this one. Arc sine 0 is equals to 0. So here x is equals to 0. Our reference angle is 0. And then this side, second fraction half. So here x equals to 60 degrees. This side is 0 degrees. So that is where cos x less than 0 is important now. We are told we have to look our angles at second quadrant and third quadrant. our angle is equals to 180 plus or minus 0. So our general solution is going to be x is equals to 180 degrees plus k multiplied by 360 degrees. And then another important thing, this k doesn't have to be k, because we have to know what type of k are we talking about. So here we can say k is integer. So this means k, it must be 1 or 2 or 0 or -1 or negative something. It is not going to be, can't be 0.5. It has to be 1, it has to be integer. So this one, I think it must have a mark. If you can leave this one, then you're gonna lose some marks. And then this side, x in those quadrants is 180 degrees plus or minus 60 degrees. So x is equals to 120 degrees. Again, x and equals to 240 degrees when you add. So our general solution is going to be x equals to 120 degrees plus k is 360 degrees. Then k is an integer. Again, x equals to 240 degrees plus k multiplied by 360. Again, we must mention k is an integer. So these are the general solutions that we are talking about. It must be in a second quadrant or third quadrant. 120 is the second quadrant and 240 is the third quadrant. And then 180 is in between. So it's still correct. It's in between those quadrants. So our general solution now 1, 2, 3.